So first of all, we are only going to apply this to right angle triangles. And you can see here I've labelled some sides of the triangle. So this side here is called the hypotenuse. The reason for that is because it's the longest side, or in other words, it's the side opposite the right angle. This side here is the opposite side, and that's because it's opposite the angle involved in the question. So this is the angle here, and you can see that side is opposite. This side here is called the adjacent. The reason for that is because it has the right angle and the angle involved in the question. This symbol here is called theta. That just means the missing angle. Okay, so now we've been through how to label the sides. We're going to look at our trigonometry ratios, so sine, cos and tan, and how we're going to use them to find missing angles and missing lengths of right angle triangles. So this acronym here, we've got SOH, CAH, TOA. You've likely heard of that before, so I'll go through what it actually stands for. So SOH stands for sine equals opposite over hypotenuse, as you can see here. CAH stands for cos theta equals adjacent over hypotenuse, and TOA stands for tan theta equals opposite over adjacent. They're all theta. I know I didn't say it for sine, but they all have theta. Okay, and the way we use this acronym is if the question is involving the opposite and the hypotenuse, we use sine to work out our missing angle or the missing length. If the question involves the adjacent side and the hypotenuse side, then we're going to use cos to find the missing angle or the missing side. And lastly, if the question involves the opposite and the adjacent, we're going to use tan to work out the missing angle or the missing side. Let's move on to a question now. Okay, so this question here, as you can see, it wants us to find x to one decimal place. So what we do is we'd label our sides. You can see this bottom line here with 9 centimeters is going to be our adjacent, and that's because it has the right angle and the angle involved in the question. X is going to be our opposite. That's because it's opposite the angle involved in the question. So this side would be our hypotenuse because it's the longest side, but it's not involved in this question, so I'm not going to label that side. So as you can see, we have the opposite and adjacent involved in this question. So because we have O and A, that means we're going to use tan, TOA. And we're going to set up our equation like so. So we're going to get tan theta equals opposite over adjacent. Then we're going to fill in the values we know. So we know that theta is 34. So we put that in. Our opposite's x, so we're going to put x, and that's going to be over 9. Then we're going to rearrange to get x by itself. So we're going to times both sides by 9, giving us 9 tan 34, like that. Okay, so in our calculator, we are going to put in 9 tan 34, and that should give us our answer of 6.1 centimeters to one decimal place. Okay, so next question. So we're going to start again by labeling the sides involved in the question. We have our angle here and our right angle. So this side with the 7 centimeters is going to be our adjacent. The longest side opposite the right angle is going to be our hypotenuse. So you can see we have A and H. We look at these and see which involves A and H, and that's going to be CAH. So the formula that we're going to set up is going to be cos. So that was our theta, so we're going to put x, so cos x equals adjacent over hypotenuse, so 7 over 10. Then we're going to rearrange this to find x. So when finding a missing angle, we use the inverse of whatever trigonometry ratio is there. So what I mean is we're going to write x equals cos to the minus power of minus 1. So that's the inverse. You'll see that on your calculator if you press shift and then the cos button, and then in brackets we're just going to times that by 7 over 10 as above. So we put that into our calculator, and the answer to one decimal place should be 45.6 degrees. Okay, so this question, Slightly more complicated question. We've got two triangles involved in it. Find ACB to 1 decimal place. So first of all, we need to find ACB, and that's going to be ACB. That's going to be this angle here. So we need to find that angle there. If we look at this triangle here, the ABC triangle, we don't have enough information to find that angle straight off the bat. So we need to use this triangle below. So we're going to use that triangle below to find the mutual side that these two triangles share, which is BC. So we're going to try and find BC. I'm going to label that as X for now, and then we're going to label our bottom triangle. So that BC there is going to be opposite. So that's going to be our opposite side if we look at the bottom triangle, and 2.9 is going to be our adjacent because it shares the angle and the right angle. So we're going to set that up. We're going to use TOA, tan, because it's got O and A involved. So we've got tan, taking that angle there, 21, equals opposite, so X over adjacent, which is 2.9. Next, we're going to rearrange this equation by timesing by 2.9 on both sides. So that's going to give us, I'm just going to flip it around, it's going to give us 2.9 times tan 21. So X is going to equal, let me put this in the calculator, 2.9 tan. So that's going to be 1.1 centimeters. So we're going to use that information there. Let me write it in fact, 1.1, to now find theta. So if we look at this above triangle now, we have our adjacent side and we have the longest side, the hypotenuse. So A and H, we're going to use so cos. So I'm going to set up cos, and theta, I'm just going to put X. So cos X equals adjacent over hypotenuse, so 1.1 over 6.4. And like the previous question, we need to use the inverse of cos, and then we're going to times that by our fraction. And that gives us 80.1 degrees. Okay, so that's everything for today's video. If you have any questions, just put it in the comments or reach out to me on socials. There will be some practice worksheet links in the description below, so check that out. And thanks for watching.